Hey guys, welcome back to video number 3 in our polynomials unit. Today we will be looking at synthetic division. Synthetic division is one of two methods used to divide polynomials. When we are dividing polynomials, we are trying to answer two questions. If you look right here on the notes page that's in your packet, you will see questions to answer. Two of the things that we are trying to answer would be, is our divisor a factor of the polynomial? And then, is the 0 that we get when setting up the divisor a solution to the polynomial? That may or may not make a whole lot of sense right now, but I think it will make more sense as we go through. So one method that we can use to divide polynomials is called long division. And if you look right here, I wrote that it looks like regular old long division that you learned how to do back when you were in the 5th grade. I'm going to show it to you so that you can see what it is. It is perfect if our coefficient in our divisor is something other than 1, but because this is a summer learning packet, I thought we would focus on synthetic division. But I am going to show you what long division looks like. But first, I want to just come over here to the side of our paper, and I want to remind you that when we have a regular old long division problem, we have a dividend, we have a divisor, and then the answer to our division problem is called the quotient. So same thing in polynomials and same thing with division. We have a dividend and a divisor and a quotient, only they looked a little different than what they did when you were in the 5th grade. So my top one, that would be my dividend. And then my bottom one is my divisor. So I am dividing 2x squared minus 3x minus 2. I'm dividing that by x minus 2. Because I'm checking to see, is x minus 2 a factor, and then is the 0 I would get if I set x minus 2 equal to 0, which would be x equals 2, is that a solution? So, way back when you were in the 5th grade, you learned that if I had 35 as my dividend divided by 5 as my divisor, 7 would be my quotient. 7 would be my answer because 7 times 5 is 35. And you can kind of look at it as 7 times 5 is 35. Well, if my quotient needs to be something other than a single digit, so if I had 210 divided by 3, well, 3 won't go into 2, but it will go into 21. So 7 times 3 is 21. I line it up in my tens place. 21 minus 21 is 0. I can't forget to bring down my 0. 0 times 3 is 0, so my final answer, my quotient, is 70. So that's the division you learned back in the 5th grade. We're going to apply that same idea over here. Change colors. We'll see. We'll do, we'll try orange. We'll see if that works. So I asked myself, what would I multiply x by to get 2x squared? Well, I'd have to multiply it by 2, and then I would need to multiply x by x to get x squared. So I'm not going to start with this first one. There are 2 terms here in my divisor, so I'm going to start right here with my first 2 terms here. So if I would have to multiply 2x by x to get 2x squared, I'm going to line it up right here, my second term. 2 terms, 2 terms. Lining up everything with division is very, very important. Well, that doesn't want to undo. Let's see if we can do it this way. There we go. No more orange lines. We didn't need those. So I'll put this 2x here. Well then, I have to multiply. I have to multiply 2x by 2, 2x by x squared. So actually, it's not 2x by 2, it's really 2x by negative 2. And for some of us, if we can't see what we're doing up here, we could come over to the side and we could say 2x times negative 2, and then we could say 2x times x, because I'm multiplying it by both terms of my divisor. Well, 2x times negative 2 is negative 4x, and then 2x times x would be 2x squared. Well, right here, what do we do? We said 7 times 3 is 21, and we said 21 minus 21 is a big fat 0. We subtracted. Well, over here, I've got to subtract 2. So if I subtract my 2x squared, I also have to subtract my 4x. But it already has a subtraction sign in front of it, so 2 subtraction signs make a positive sign. So now then I have that fixed. Negative 3 plus 4 is 1x. 2x minus 2x squared is 0. We always want this first one to cancel out. Bring down my negative 2. Well, what do I multiply by x to get x? That's easy. It would just be x. That's a positive x. So then I would say x times negative 2 and x times x. So that would be a negative 2 hang on, guys. Let Miss Wilkins erase some of this. Let's fix that. I don't need to multiply x. Whoops. There we go, y'all. Took me a minute to get that fixed. I'm not going to multiply x by x to get x. I'm going to multiply everything by 1 to get x. See, we weren't in class for you to catch that mistake of mine. Now it's fixed. Let's erase that too. So it would be x times 1 and then 1 times negative 2. There we go. So 1 times negative 2 is negative 2, and then 1 times x is x. Well, just like over here where I subtracted, I have to subtract here. So I subtract x, and then to subtract that, it becomes a positive. Negative 2 plus 2 is 0. X minus x is 0. If I end up with a remainder of 0, then I can say my divisor is a factor of that polynomial, and then the 0 that I get when I set my factor equal to 0, which is x equals 2, I can say that is a root or a solution or a 0 of that polynomial. Just a quick reminder that roots, solutions, zeros, and x-intercepts refer to where is the x-axis. And those 4 terms are used interchangeably. Alright, so let me go back and let me fix my spelling mistake. So we need a EA BLY. There we go. So they're used interchangeably. So you might hear a math teacher, or you might hear somebody say a root, and they might say a solution, or they might say a 0, but it all means the same thing. And how do I get to this x equals 2 from my factor? Well, I take my factor of x minus 2 and I set it equal to 0, and then I solve for x. To solve for x, I would add 2 to both sides, and I would say x equals 2, and I am checking to see if that is a root or a 0 or a solution. Now, this thing right here, this synthetic substitution, we're not going to go over how to do that, but what we need to know is that it is a thing and that it leads to synthetic division, which is what I'm about to show you. Now right here, we have a note. It says, so we now have a strategy of using synthetic division to help factor polynomials. If we obtain a 0 remainder, which we talked about that above, we have found a factor of the polynomial. So this example says to use synthetic division to divide 3x cubed minus 2x plus 7 by x plus 2. Well, to write that out in division form with a fraction bar, we would put 3x cubed minus 2x plus 7 in our numerator divided by x plus 2 in our denominator. And again, our questions to answer, we're going to answer is my divisor of x plus 2, a factor of that polynomial. And then if I take my x plus 2 and I set it equal to 0 and I get x equals negative 2, is that a solution to that polynomial equation? So here's a very special thing that we need to remember. When using synthetic division, so it's right here, when using synthetic division, the variable must be listed in descending order of the exponents. Descending means it's going down. So if I look at my dividend, 3x cubed minus 2x, what am I missing? I am missing an x squared. Well, I have to put that in. So I have to rewrite my problem so that I have that in there. So I would say 3x cubed plus 0x squared minus 2x plus 7. That helps me to not leave anything out. I'm going to need that coefficient of 0 in front of that x squared, or my synthetic division won't work. So just remember, if you're missing a variable, in this case we were missing x squared, I have to put it in or I won't get my correct answer. Alrighty, so we have rewritten our polynomial, so now we are going to do this synthetic division. So really we have a division house turned upside down, and that's what this line is right here. It's already drawn for us, it's upside down. So now I'm going to take my coefficients of each of my variables and I'm going to write them across the top. So I have a 3 as my first coefficient, a 0 as my second coefficient, a negative 2 as my third coefficient, and a 7 as my constant. So I'm going to skip a little space in between and I'm going to write them across the top. The next thing I need to know is I need to know what number do I put here. How do I know what's part of my synthetic division? Well, to figure out what that number is, I take my divisor. In this case, my divisor is x plus 2, and I set that equal to 0. So I would say x plus 2 equals 0, and then I'm going to solve for x. So I'm going to subtract 2 from both sides, and I end up with x equals negative 2. Well, now I have the number that I'm going to put right here, outside of my upside down division house. So what I'm going to do is I'm going to start by bringing my 3 down. And then I'm going to do some multiplication. Negative 2 times 3 is negative 6. 0 plus negative 6 is negative 6. And I do the same thing again. Negative 2 times negative 6 is positive 12. Negative 2 plus 12 is 10. Negative 2 times 10 is negative 20. 7 plus negative 20 is negative 13. The very last number, I'm going to change colors because we're getting a lot of information on this piece of paper. So this very last number, if it's not 0, is called my remainder. So in this case, it was not 0. So I have a remainder. So I can come over here to these two questions that we started out with at the very beginning. Is x plus 2 a factor? Is x equals negative 2 a solution? The answer to both of those questions is no, because I ended up with a remainder when I did my synthetic division. Sometimes you can stop. You can answer those questions and you can stop because you were just asked, is the divisor a factor? But sometimes we have to keep going. If we have to keep going, well, we need to be able to write our answer in some way so that it looks like the polynomial. So, how do I do that? Well, I look right here, and I started with an x cubed. Well, whatever I started with, my answer is going to be one exponent less. So if I started with an x cubed, then my answer is going to have an x squared as my first variable, and then an x as my second variable, and then I have a constant, and then I have a remainder. So my final answer would be 3x squared minus 6x plus 10 minus, I'm going to write my remainder as a fraction. I'm going to put the 13 in my numerator, and I'm going to put it over my divisor. Now, what was my divisor? I go all the way back up here to my original problem. My divisor was x plus 2. And I do apologize that I had to write that very small. We took a lot of notes on this piece of paper. But my final answer is 3x squared minus 6x plus 10 minus my remainder of 13 divided by x plus 2. So that may seem a little overwhelming about synthetic division, but let's flip over to the next page in our packet and let's do some practice problems and see if it gets better. So here we are on page 2, and we have 4 practice problems. So the first thing that we're going to do, we're going to look at this example 1 right here. My instructions tell me to use synthetic division to divide f of x by d of x. So I've already written out my numerator and my denominator, my dividend and my divisor. So the first thing I need to check is check our exponents. Make sure they are in descending order. So we'll put a note right here. Check exponents. And remember what we mean by descending order. If we start with an x cubed, we are followed by a squared and then a plain x and then a constant. Or if I start with x to the 4th, I'm followed by a cubed and then squared and then a plain x and then a constant. So yes, this one's in descending order. So I'm going to draw my upside down division house, and I'm going to write down my coefficients. So my coefficients of x cubed right there is 1. My coefficient of x squared is 4. My coefficient of x is -1. And then my constant is -1. So that was step 1. Step 2 is I need to know what number do I put here. So to find that number, I take my divisor, my x plus 2, and remember I set it equal to 0, and I solve for x. So I subtract 2 from both sides to solve for x. So x equals -2, and that's the number that goes right here. So I take my divisor, set it equal to 0 to get my -2. bring down my 1, and then I do my multiplication. So negative 2 times 1 is negative 2. 4 plus negative 2 is 2. Negative 2 times 2 is negative 4. Negative 1 plus negative 4 is negative 5. Negative 2 times negative 5 is positive 10. Negative 1 plus 10 is 9. So I have a remainder. I'm going to use an R. So then the questions that we would ask is x plus 2 a factor? No, because we have a remainder. Is x equals negative 2 a solution, or a root, or a 0? No, because we had a remainder. And that is why we are doing synthetic division, so we can answer questions like this, or so we could factor a polynomial that might be hard to factor otherwise. So to write this answer out, I started with x cubed. So one thing less than x cubed is x squared. So we have 1x squared and a 2x and a constant and a remainder. So my answer is x squared plus 2x minus 5 plus my remainder, written as a fraction, over my divisor, x plus 2. It's okay that we wrote over that little part right there. So now then, I want you to pause the video if you need to. I want you to look at our example number 2 here. I want you to see if you can A, identify your dividend and your divisor, B, check to see if your exponents are in descending order, and C, set up your upside down division house. Alrighty, so you paused the video and you kind of checked it out. So the questions I would ask you now would be, are my exponents in descending order? Well, cube, squared, x, and then constant? Yes, they are. So write down my coefficients: 2, negative 11, 3, 36. I need to know what my number is that goes here. To get that number, I'm going to take my divisor of x minus 3. I'm going to set it equal to 0. I'm going to solve for x. I'm going to end up with x equals 3. And 3 is the number I'm going to put outside my division house. I'm going to bring down my 2. And I'm going to start with my multiplication. 3 times 2 is 6. Negative 11 plus 6 is negative 5. 3 times negative 5 is negative 15. 3 plus negative 15 is negative 12. 3 times negative 12 is negative 36. 36 minus 36 is 0. So 0 is my remainder. So now, those same two questions, is x minus 3 a factor? And is x equals 3 a solution? Well, the answer to both of those is yes, because we had no remainder. So now that's my first one that I've been able to say I found a factor of my polynomial. And so to write my final answer, remember, started with x cubed, so this would have an x squared, and this would have an x. So my final answer is 2x squared minus 5x minus 12. So why don't you pause the video one more time, check to see if you can work example 3. So I've drawn our division house for us while you were pausing the video and looking at it. And so that first thing that I'm going to do is I'm going to check my exponents. And look, I go from an x to the fourth to an x squared. I need an x cubed in there, don't I? So I would rewrite it as x to the fourth plus 0x cubed plus 4x squared minus x minus 1. So 1, 0, 4, -1, and -1. And then I take my x plus 1, I set it equal to 0, subtract 1 from both sides, x equals -1, and that's my number I put here. Bring down my 1, -1 times 1 is -1, 0 minus 1 is -1, -1 times -1 is +1, 4 plus 1 is 5, -1 times 5 is -5, -1 times plus -5 is -6, -1 times -6 is +6, -1 plus 6 is +5. So we had an x to the fourth, so now I'm going to have an x to the third, x squared, an x, a constant, and a remainder. So my final answer is x to the third minus x squared plus 5x minus 6 plus my remainder over my divisor of x plus 1. One more. So why don't you pause that video one last time. See if you can set this one up. See if you can work this one out. And then we'll work it out together. So, are we missing any exponents? We are. We're missing 2. We have x to the fourth plus 3x cubed plus 0x squared plus 0x minus 28. Alright, so we have rewritten our polynomial so that we have our descending power of exponents. Then we are going to write our coefficients down. Our coefficients that we write down are going to be 1, 3, 0, 0, and -28. And by now I think you know the routine. We're going to take our divisor of x minus 2, set it equal to 0, solve for x, and now x equals 2. That is the number I put here. Bring down my 1 and do my multiplication. 2 times 1 is 2, 3 plus 2 is 5, 2 times 5 is 10, 0 plus 10 is 10, 2 times 10 is 20, 0 plus 20 is 20, 2 times 20 is 40, -28 plus 40 is 12. So then I start with an x to the fourth. So then I will start with x to the third in my answer. And I have a remainder. So my final answer is going to be x to the third plus 5x squared plus 10x plus 20 plus my remainder of 12 in my numerator divided by my divisor of x minus 2. And this concludes our polynomial series. Our fourth video will be on quadratics, and we will use some of the things that we learned in this polynomial series to solve some quadratic equations.